Alrighty, we're going to go over Friday's in-class assignment, the 3.5 homework. And I'm going to give you the answers for all the problems. Bear with me, it's probably going to be a long video. Number 1 reads, Renee worked a total of 16 1/5 hours last week. She spent 1/3 of that time reviewing reports. How many hours did she spend reviewing reports? The first thing we need to do is underline what is important. Looking at this, I can see a total of 16 1/5 hours, and she spent 1/3 of that time reviewing reports. And we squiggle underline our question, how many hours did she spend reviewing reports? This question is a multiplication problem. So I'm going to take my total time of 16 1/5 hours. I'm going to multiply that by 1/3 to find out how many hours she actually spent while working. We know she spent 1/3 of 16 1/5, but what does that mean? Before I can begin to multiply straight across, I see I have a mixed number. And this mixed number, 16 1/5, is the same as saying I have 16 groups of 5 and 1 left over. Groups of tells me multiply. So I have 16 groups of 5, which is the same as saying 16 times 5, and 1 left over. So I just add 1 more onto that. 16 times 5. Let's see, 6 times 5 is 30. 1 times 5 is 5, plus 3 is 8. So 80 plus 1, which is 81. Okay, erase this to give me more space. And I'm going to come right back up here. 81 is going to now be my numerator, all over 5, as that's my original denominator, times 1/3. Now I can multiply straight across. 81 times 1 is 81. 5 times 3 is 15. 81 is bigger than 15, which means I need to find my multiples of 15 to see how many times 15 can go into 81 to remake this into a mixed number. So my multiples of 15, let's see, 15 times 1 is 15, times 2 is 30, times 3 is 45, times 4 is 60, times 5 is 75, times 6 is 90. Ooh, 90 is bigger than 81. So I'm going to have to look at this 75. This tells me 15 can go into 81 1, 2, 3, 4, 5 whole times. And there's something left over. To find out what that something is, I take 81 and I subtract 75 from it, because that's what 5 times 15 gets me. And this becomes a 6. So I know 5 and 6 15ths, telling me I have 5 groups of 15 and 6 left over. When looking at my 6 and 15 though, I can see something else can go into these. I can simplify this. I keep my 5 the same. I know 3 can go into 6 and 15. 6 divided by 3, I'm taking group of 3 out. Groups of 3 out, I mean. And I have 2. 15 divided by 3 is 5. So 5 2/5, and the unit, time, hours. Box it in so Miss Reams knows that that's the answer you want her to check. And we move on to the next problem. Number 2. Alicia added 5 1/4 quarts of water and 4 2/5 quarts of a cleaning solution to a large bucket. How much total liquid did she add to the bucket? Show your work. First up, we underline what is important in this. Well, we know 5 1/4 quarts of water and 4 2/5 quarts of a cleaning solution. And our question, how much total liquid did she add to the bucket? While reading this, I noticed some words that told us what kind of math problem this is going to be. We have the word total and added. These two words tell me this is going to be an addition problem. So I'm going to write it out. 5 1/4 plus 4 2/5 equals, I don't know yet, so I'm going to give it the letter Y to say, I don't know, but I'm going to find out the answer. First thing I notice is I have mixed numbers here. 5 1/4 tells me I have 5 groups of 4 and 1 left over, which is the same as saying 5 times 4 plus 1. 5 times 4 is 20 plus 1, so 21 over 4. And this 4 2/5 is the same as saying 4 groups of 5 and 2 left over. Or the same as saying 4 times 5 plus 2, which is 4 times 5 is 20, plus 2, which is 22, all over 5. So now I can rewrite my problem to add them back together. I have 21, oh that's really bright, let me try a different color. 21 over 4 plus 22 over 5. But the next thing I notice is when I'm adding, I know I need to make sure my denominators are the same, and currently I do not have a common denominator. So I'm going to have to find the least common multiple between 4 and 5 to find out what my fraction really should be over. So first up, I'm going to start with 4. Let's see. My multiples of 4, I know 4 times 1 is 4, times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20. And I always go to 5 in case I don't need to go any higher, and we see if I need to continue afterwards. And I start next with 5. 5 times 1 is 5, times 2 is 10, times 3 is 15, times 4 is 20, times 5 is 25. Then I look and see, do I currently have anything in common? And I do. I have a 20 and a 20. And there's nothing less that they have in common besides 20. So our least common multiple is 20. And I'm going to erase that bit so I have space to continue my actual problem. But remembering 20, I'll put 20 over here. Erase, erase, erase. Boop. So now I need to rewrite my math problem with my denominator of 20. To get 20 from 4, I did 4 times 5. And whatever I do to the bottom, I need to do to the top. 21 times 5. 1 times 5 is 5, 2 times 5 is 10. And I plug it in. And to get to 20 with my 5, I times that by 4. Whatever I do to the bottom, I do to the top. 22 times 4. 2 times 4 is 8. 2 times 4 is 8. 88. And now I can add straight across. I know my denominator is going to stay 20. I don't need to add them together. Just going to keep it 20. And I do 105 plus 88. 5 plus 8 is 13. 0 plus 8 is 8 plus 1 is 9. And bring down my 1. 193. But, oh! 193 is bigger than 20. So I need to see how many times 20 can go into 193. I could find my multiples of 20 and go 20, 40, 60, 80. I could do that until I reach what I need to. But I know if I keep doing that, I'm going to end up with 20 times 10, which gets me 200. And that's too much, because we cannot pass 193. So I'm going to try 20 times 9 and see what that gets me. 0 times 9 is 0, 2 times 9 is 18, and 180 is less than 193. Erase my work. That 8 does not want to erase. Try again. There we go. So I know I'm going to have a huge 9 pulled out. And I'm going to do 193 minus 180 to find out what I have left over. 3 minus 0 is 3. 9 minus 8 is 1. 1 minus 1 is nothing. So I have 9 and 13 left over out of 20. My unit of quarts. And I box it in so Miss Reams knows that's the answer she wants to be looking at. And we move on to the next problem. Number 3 says, find the value of the expression. Write the answer in simplest form. The expression they gave us was 5/12 minus 1/10. So boom, we know right away we're subtracting. They told us that in the problem. One thing I know when I am subtracting, just like adding fractions, is I need them to have a common denominator. Currently, I don't have that. So I need to find the least common multiple between 12 and 10. To do that, I start by finding my multiples of 12. 12 times 1 is 12. Times 2 is 24. Times 3 is 36. Times 4 is 48. Times 5 is 60. Then I stop at 5 and only continue later if I need to. And I move on to 10. 10 times 1 is 10, times 2 is 20, times 3 is 30, times 4 is 40, times 5 is 50. And I look, do I have anything in common? Not yet, so I need to continue. I'm going to continue with 10 to see if I can somehow get 60. And oh, look at I can't. Currently, I have 60, 60, and there's nothing less on either side. So 60, our least common multiple, is 60. That means when I rewrite my problem, it's going to now be over the number 60. To get to 60 from 12, I did 12 times 1, 2, 3, 4, 5. And whatever I do to the bottom, I do to the top. 5 times 5 is 25. To get to 60 with 10, I did 10 times 1, 2, 3, 4, 5, 6. Whatever I do to the bottom, I do to the top. 1 times 6 is 6. Put an equal sign. It's going to now be over 60, because remember, subtracting and adding fractions, we just keep the bottom number the same until we need to at the very end. And we subtract. And we subtract 25 minus 6. Cancel that. 15 minus 6 is 9. Bring down the 1. So 19 over 60. I look at it, there's nothing that can go into 19 and 60 besides 1, and they did not give me a unit, so I just box it in and move on. Number 4 says, Kyle runs 3 1/4 miles in 22 3/4 minutes. He runs each mile in the same number of minutes. How many minutes does it take Kyle to run a mile? First up, we underline what's important. He runs 3 1/4 miles in 22 3/4 minutes. We know he runs each mile same number of minutes. And we squiggle underline our question. How many minutes does it take Kyle to run a mile? I know while I'm writing this, I'm going to have to find out minutes per mile to find out how many minutes equals 1 mile. And I know this line here is a fancy way of saying divide. So this is going to be a division problem. And if I'm keeping it as minutes per mile, that means my first number is going to have to be in minutes. So 22 3/4 goes first, divided by the miles, 3 1/4, to find out how many minutes he will run in 1 mile. Before I can divide this, I need to see if I have any mixed numbers. And I do. 22 3/4 is the same as saying 22 groups of 4, or 22 times 4, which is 88, plus 3, which is 91 over 4, divided by 3 1/4 is the same as saying 3 groups of 4, or 3 times 4, which is 12, plus 1, which is 13 over 4. And then I can start my problem. I know I'm going to have to do keep, change, flip. I'm going to keep 91 over 4. I'm going to change my division to be multiplication. And I'm going to flip or find the reciprocal of 13 over 4, which is 4 over 13. And multiply, I can multiply straight across. A little bit trickier, but 91 times 4 is 364 over 4 times 13, which is 52. Then I need to find out how many times 52 can go into 364 and see if there's anything left over. But again, I know this sign right here means divide. So I'm just going to get a calculator and I'm going to do 364 divided by 52. 364 divided by 52, which gets me 7. So 7 minutes per mile. And I box it in to say, hey, Miss Reams, I want you to check that that's my correct answer. And I can move on to the next problem. Number 5. Mary buys a bag of nuts that weighs 2 1/4 pounds. After a week, she has eaten 2/3 of the nuts. How many pounds of nuts has she eaten? First up, we underline what is important. First, we know bag of nuts weighs 2 1/4 pounds. And after a week, she ate 2/3 of the nuts. And our question, well, how many pounds of nuts has she eaten? We know we started with 2 1/4 pounds and she ate 2/3 of the bag, but how much is that in pounds? And when we're asking that kind of question, we know this is going to be a multiplication question. Multiplication operation. So we can find out, well, how many pounds did she eat? We can start with 2 1/4, and we are timesing that by 2/3 to find out, well, how many pounds? How much has she eaten? We look and see, I have a mixed number here, 2 1/4. I know that's the same as saying 2 groups of 4 and 1 left over. 2 groups of 4 is 8, and 1 left over is 9 over 4, the denominator we started with, times 2/3. And I can multiply straight across. Oops, moving my page. 9 times 2 is 18. 4 times 3 is 12. 18 is much bigger than 12. Well, maybe not much bigger, but it is bigger than 12. So I can reduce this. 12 I know can go into 18 one time. And I will have 6 over 12 left over. And I know also that 6 over 12, I can take something out of both of these. I can take sets of 6 out of both of these. Because 6 over 12 is the same as saying 1/2. So 1.5, and the units, pounds, and I box it in to say, hey, that's my answer, and I can move on. Mary has eaten 1.5 pounds of nuts in 1 week. I think she needs to eat some vegetables instead. For problems 6 through 11, they want us to perform the indicated operation. This part is really nice because we don't have to figure out what kind of math problem we're doing. They have already told us. So number 6 says 5 3/4 plus 1/10. First thing I have to do is change my mixed number to be a fraction greater than 1, or an improper fraction. 5 3/4 is the same as saying 5 groups of 4 and 3 left over. 5 groups of 4 is 5 times 4, or 20, plus 3 is 23, all over 4, plus 1/10 is just the same. When I'm adding, I need to have a common denominator. I know for sure 4 and 10 can both go into 40, so I could use that. But the lowest number they both can go into, which will save me a lot of stress in the long run, is 20. So these are going to be over the number 20. Equals something over 20. To get to 20 with 4, I did 4 times 5, because that equals 20. I gotta do the same up here. So 23 times 5, ooh, that 2 looks really funky. 3 times 5 is 15, 2 times 5 is 10, plus 1 is 11. Erase so I have room. And to get 10 to be a 20, I times that by 2, because 10 times 2 is 20. And I do that to the top. 1 times 2 is 2. And I can now add straight across, keeping my denominators the same, 20. 115 plus 2 gets me an answer of 117. And I need to find out 117 over 20, which is an improper fraction because it's a fraction greater than 1. And I need to make this now into a mixed number for my final answer. I need to see how many times 20 can go into 117. So I list my multiples of 20. 20, 40, 60, 80, 100, 120. 120 is bigger than 117. So I know, alright, we can go into here this many times. 1, 2, 3, 4, 5. So 5, what I pull out, 117 minus 100 gets me 17 over 20. And I look and see, can I reduce this any more than I already have? The answer is no, they did not give me a unit. So I box in 5 and 17/20, and I can move on to the next problem. Number 7. 4 3/5 minus 2 1/6. First thing I need to do is make these mixed numbers into improper fractions, or fractions greater than 1. 4 3/5 is the same as saying 4 sets of 5, or 4 times 5, which is 20, plus 3, which is 23/5, minus 2 1/6, which is the same as saying 2 groups of 6, or 2 times 6, which is 12, plus 1, which is 13. And I know when I am subtracting fractions, I need to make sure I have a common denominator. Currently, I do not have a common denominator. 5 and 6 are not the same number. So I would have to list out my multiples of 5 and 6 to find the least common multiple between the two. When doing that, I would see that the least common multiple of 5 and 6 is 30. So this is going to be over the number 30 minus something that's 30 equals something that is 30. What? To get 30 with my 5, I did 5 times 6, and I have to do that to the top. So 23 times 6, 3 times 6 is 18, 2 times 6 is 12, plus 1 is 138. And to get 6 into a 30, I did 6 times 5, so I have to do 13 times 5. 3 times 5 is 15, 1 times 5 is 5, plus 1 is 6. And erase I have space. Then I can do 138 minus 65. 8 minus 5 is 3. And 13 minus 6 is 7. Erase so I have space. 73 is greater than 30, so I need to see how many times 30 can go into 73 to make this into a mixed number. I know my multiples of 30 are the same as the multiples of 3, we just add a 0. So my multiples of 30 are 30, 60, 90, 120. 30 can go into 73 2 times, because 30 times 2 is 60, and anything higher than that gets me over 73. So I know this is going to be a giant number 2. And I do 73 minus 60, because that's 30 times 2, which will get me 13 over our denominator, 30. So our answer, 73 over 30, becomes 2 13/30. They didn't give me a unit, and I can't simplify anymore, so I box it in, and that's the answer. Number 8, 3 1/3 times 2 4/5. The first thing I need to do is change my mixed number to be a fraction greater than 1, or an improper fraction. 3 1/3 is the same as saying 3 groups of 3, 3 times 3, and 1 left over. 3 times 3 is 9, plus 1 is 10 over 3. Times 2 4/5 is the same as saying 2 groups of 5, or 2 times 5, which is 10, and 4 left over, which is 14 over 5. And I can multiply straight across. 10 times 14 is 140. I know that because 1 times 14 is 14, and then we add a 0. And 3 times 5 is 15. I can find out how many times 15 can go into 140 by listing out my multiples of 15. 15, 30, 45, 60, 75, 90, 105, and I'm running out of space. 120, 135. Oop, that's as close as I can get without going over. So 15 can go into 140. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So 9 is what I'm going to pull out. 9. 140 minus 135 gets me 5 over 15. And before I box it in, I can see that 5 over 15 I can simplify because 5 can go into both of these numbers. So I divide each side by 5, which will equal 9, because that'll stay the same. 5 divided by 5 is 1. 15 divided by 5 is 3. They did not give me any units, so I box it in, and I can move on to the next problem. Number 9. 4.5 divided by 4 5/8. First thing I need to do is change my mixed numbers to be a fraction greater than 1, or an improper fraction. 4 1/2 is the same as saying 4 groups of 2, or 4 times 2, which is 8, plus 1, which is 9, over our denominator. And 4 5/8 is the same as saying 4 groups of 8, or 4 times 8, which is 32, plus 5, which is 37, all over 8. Then I can apply keep, change, flip. I'm going to keep my 9 over 2 the same. I'm going to change my division to be multiplication. And I'm going to flip, or find the reciprocal of 37 over 8, which is 8 over 37. I can multiply this straight across. Oops. 9 times 8 is 72. And 2 times 37 is 74. I can see that I can at least take a 2 out of both of these numbers because they're both even, and I know 2 can always go into even numbers. Maybe there's a larger number that can go into both, but for sure I know 2 can, so I'm going to start there. And I'm going to divide each side by 2 so that I can simplify this. A bit more space. 72 divided by 2, I can do that as a 72 divided by 2. And I will get the answer of 36. And 74 divided by 2 will get me 37. There's nothing else that can go into 36 and 37 evenly besides 1. And they did not give me a unit, so I box it in. And I move on to the next problem. Number 10, we have 6 1/8 divided by 3/16. The first thing I need to do is change this mixed number to be a fraction greater than 1, or an improper fraction. 6 1/8 is the same as saying 6 groups of 8, or 6 times 8, which is 48. And 1 left over, so 49 over our denominator of 8. And we can divide 3/16. That just is 3/16. Now I can apply keep, change, flip. I keep 49, over 8. I change my division to be multiplication, and I flip, or find the reciprocal of 3/16, which is 16 over 3. And now here, my problem can branch off into doing this in 2 separate ways. And I will show you both ways that we can do this. So I'll draw a little squiggle line and separate it. The first way, we just multiply straight across. And that's rather tricky to do. But 49 times 16, do the mental math, yeah, okay, 784. And our denominator, 8 times 3, which is 24. And then I can divide this. I can do 784 divided by 24 to get my answer. And the answer that that would end up giving me, I need to clear this space for later. The answer that that would end up getting me is a number of 32. No, Cortana. It'll give me 32.666666 repeated. So I know for sure I have a 32 as my main answer. And I need a fraction of this. And here's a Miss Reams fun fact. Anytime you get a decimal that ends in something that looks like this, or a bunch of 6s and a 7, they mean the same thing. That fraction is going to be 2/3. So I got an answer of 32.66666666 repeated forever and eternity. So that's going to be 32 2/3, and I can box it in. The other way we could do this, my problem of 49 over 8 times 16 over 3. I know by looking at this, I at least know my 8 and 16 that are kitty corner, because it's multiply now, they have something in common. They both have an 8 in common. So I can take a chunk 8 out of here. So 8 divided by 8 is 1, and 16 divided by 8 is 2. I don't know 49 and 3 off the top of my head. I don't really think that 3 can go into 49, so I'll just leave those the same. Doesn't matter to me. And now my problem reads 49 over 1 times 2 over 3. And that's a little bit easier to do in my head. 49 times 16 was challenging, but 49 times 2, 9 times 2 is 18, 4 times 2 is 8, plus 1 is 9. So that gives me 98 divided by 1 times 3, which is 3. And I can do that as well. 98 divided by 3, 3 into 9, 3 times. 8 down, 3 into 8, 2 times. It's going to be a 2. I have to put a decimal point here. 3 can go into 20.6 times. And I'm going to keep getting a 2, and I have to keep adding a 0 and bringing it down. So 32.66666 is the same that I would get here. And so my answer is 32 and 32.66666 repeated, or 2/3. Box it in. These are the same. They got me the same answer. So these are the same. Either of them are fine to do, but box it in and move on to the last problem. Number 11, our final one. 3 4/5 times 1 2/3. First thing I have to do is change my mixed numbers to be fractions greater than 1. 3 4/5 is 3 groups of 5 plus 4, so 19 over 5. Times 1 2/3, which is 1 group of 3 plus 2, or 5/3. Again, we can do this problem one of two ways, and I will draw the squiggle to show. I can do multiply straight across. 19 times 5. 9 times 5 is 45. 1 times 5 is 5, plus 4 is 4. No, it's 9. I thought that looked funky. So I'll get 95 over 5 times 3, which is 15. I can find out how many times 15 can go into 95, and I did that earlier with my finding multiples for a different problem. And I know I can get in there 6 times with 5 over 15 left over. And I can simplify this to be 6 times, divide each side by 5 because 5 can go into both, and get 1/3. Box it in, and I'm done. The other way we can do this, 19 over 5 times 5 over 3. I can see right here that these 5s that are kitty corner from each other have something in common. They have a 5 in common with each other. So I can cross them out, take a 5 away. 5 divided by 5 is 1. 5 divided by 5 is 1. And now my problem is 19 times 1, which is 19, over 1 times 3, which is 3. And that's a bit easier to do in my head. I know 3 can go into 19 6 times. 3 times 6 is 18. And 19 minus 18 is 1 over 3. And I box it in. These got me the same answer. So both of the ways to do this are fine. 6 1/3 is our answer. I told y'all at the beginning that this was going to be a long video, so thank you for sticking around. If you did, let me know on your assignment. Type in the word wowza with like 4 exclamation points, and I will give you a bonus point for sitting through this entire 43-minute video. I hope this answered any questions that you had to get you better prepared for our test on Tuesday, and I hope you have a great rest of your weekend. Bye-bye!